Now that we have a stronger understanding of radical functions, let's use what we know to find the domain, range, and intercepts for the given function here. Remember that finding the domain is like finding the restrictions on x. We know that for a radical function, the radicand, which is the expression under the root sign, must be greater than or equal to 0. Let's isolate x. It's worth noting that in the first step, had we subtracted 9 from either side, we would have been dividing by a negative coefficient of negative 0.5. When we divide or multiply an inequation through by a negative sign, remember to change the direction of the inequality. In this case, there is no need to do that. However, I did rewrite 9 greater than or equal to 0.5x in the other direction, which is to say I put the x on the left side of the inequation, and that's why I changed my inequation to a less than. So our domain is all values of x less than or equal to 18. And you can check that because the number less than 18 should make that radicand become positive. We'll confirm it graphically in a little bit. To find the range of a radical function, we usually verify graphically, but we can think this one through. Our basic radical function, without any translations, has a range that is greater than or equal to 0. Two things can change this. If there's been a vertical translation, then the number we're comparing to will change. If the a value, which is to say the number out in front of the root sign, is negative, then our range will be less than or equal to instead of greater than or equal to. In this example, we do have a vertical stretch of 3, but that doesn't actually change the range. It's only changed if that were a negative 3. But the translation 12 units down will change our greater than or equal to 0 to greater than or equal to negative 12. Now we type this function into our graphing calculator, and if you use the window settings shown here, you should see a graph like this. Now we can confirm that our endpoint is at 18 and negative 12, our domain includes all points left of that, and our range includes all points above that. Remember that finding intercepts means replacing with zeros. So to find the x-intercept, we'll set our y value at 0. This is a radical equation. We'll need to isolate that square root and then square to get rid of it. Be careful in that last step. When we square both sides, we lose the root sign, but we don't lose the negative sign here because it was under the radical sign and with the radicand expression. So we find x is equal to negative 14. If we go back to our graph, we should see that it crosses the x-axis at negative 14. Let's find the y-intercept by replacing x with 0. We find the point 0 and negative 3 and can again confirm this graphically. Hopefully, you felt confident finding those 4 characteristics of this function.